Hi Reza, I hope you're doing well. This is Mo. Uh, in this video, I'm going to present my assignment 3. Basically, there are two parts of the assignments. Uh, on part A, we have image convolution, and on part B, we're working with neural networks. So, uh, as you know, we have some pre-coded cells that we have. I'm not going to explain these in details. I'm going to get to the question first, but just a quick overview. We're importing the libraries. We're importing our image. We're getting it from a URL, and the first image that we're plotting it, you can see it here. Um, and then we're adding some color channels, and next part we're going to work with kernels. So that's what the part one of the assignment is about. So as you can see, we are creating some kernels, applying them to the image and plotting it on the diagram. The first question, okay, so as you can see here, again, there's a horizontal kernel uh, that we are defining and applying it to the image, and we're plotting it to the diagram. So basically, a kernel or a convolution matrix is a small matrix that is used for blurring or sharpening or edge detection, and it's accomplished by doing convolution between kernels and an image. So on the first question, we are having a kernel to detect 45 degrees lines, and after applying it to the image, we are having it on the plot. So here's a difference between these two after uh, basically detecting the 45-degree lines. Here we have the same thing. The only difference is instead of 45, we are now having 135, and um, you can there's not much of a difference, but you can see the difference in the bottom of the image. We have edge detections. So we are applying the following kernels to the plot again. And here's the two difference between these two images. And again, another kernel being added to the image, which makes the line more obvious. Okay, in part B, it's all about the neural networks. So from what I understand from the assignment, it's most of the parts are pretty much the same. We're just running a model with different layers to see what are the accuracy and the overfitting. So we start from here. We're importing some libraries. We're dividing our model into training and testing. We're using the categorical, and we're basically converting our integers to floats. So this is our first model. As you can see, we have 5 different layers in the models. We have two dense layer and one 2D max boolean and flatten. Sorry. Okay. So we compile our model, and you can see the summary here. Let's get to the question. Okay. Okay. So here we are basically training our model with 50 epochs. So that's kind of like 50 loops. Um, you can see the results of each epochs here. Let me go down. Okay, that's still okay. So after we actually fitting our model with 50 epochs, you can see a plot with which is showing us the accuracy of our model. So first, the third question is basically asking us if there is any signs of overfitting, and the answer is basically yes. So if you can see here from epochs 15, um, the accuracy is 65. It's going to 65 again, and it's kind of reducing to 64. So basically it starts from here and then it reduces to 65. So that's kind of where we have the overfitting, and our epochs are start decreasing on the accuracy. So next question is how many layers we have. So we have 5 in total, as I mentioned before. And in this question, each of the layers are being explained. So Conv2D is like the most common type of convolution that is used in the 2D convolution layer, and it's usually abbreviated as conv2. The Max Poblin is a simple base decentralization process, and the purpose is basically to down sample an input representation. We have flatten. So the purpose of that is basically contain the elements from 3D to and output them to 1D. And at the end, we have dense layer, which is the most common and frequently used layer. Um, dense layer does, as I mentioned here, dense layer does the below operation on the input and return the output. Okay, so in this question, we are adding, uh, I believe, yeah, I added one extra layer to see the difference between this model and the previous one. So if I come down here, you can see the accuracy. So the accuracy between this model and the previous model, it's basically increasing. So if so the model on the top had was basically starting from 65 on epochs 15, and as you can see here, it's starting 71, and it's going up and then it decreases. So the layer basically helped us to increase the accuracy. On the next question, we are adding a dropout layer. So basically, the use of dropout layer is to fight with the overfitting, and like it kind of help us to reduce that. So as you can see, we've added a dropout layer here. Then again, we compile our model. Um, we do the 50 epochs again, and you can see the accuracy has been increased. And here I explained uh, what's the purpose of the dropout layer. So usually it's going to prevent neural networks from overfitting. All right, so in the last question, so I believe it's the last one, uh, it's just we're adding some more layers to see the difference between this and the previous one. As I said, we're basically experiencing different models with different layers. So I've added two dropouts layer, and I've added two conv to the layers. And after compiling our models, here you can see the accuracy still increases a little bit from before, from our first model, and that's basically because of our uh, dropout layers, I believe. Uh, that's pretty much for the assignment 3. Uh, hope I explained all the questions, and thanks for your time. Have a good day.